Thank you so much. So I would like to start by thanking Martha Russell and the MediaX team for inviting me to present my work today. It's a pleasure to be here. So my name is Angèle Christin, and I'm an assistant professor of communication. And I'm an ethnographer, and I was trained as a sociologist. So I come from the social science, and I study algorithmic technologies and how they shape the way we work and interact with each other. So today I'll be talking about the politics of algorithms. Now, algorithms are everywhere. So if you look at media headlines, you see things like this, right? This is from yesterday, actually. And so you see the kind of hype and fear that comes with algorithmic technologies. Algorithms are going to save us, right? They're going to make healthcare better. They're going to improve life in modern societies. But they're also really scary. Are they controlling us? Do they know everything about our lives? Can we escape the power of algorithms? They're also going to change what creativity means. Under the hammer, artwork by an algorithm is up for auction. So what does that mean? AI is now creative, right? So you also have this idea that algorithms are developing a kind of creativity of their own. So we're going to try to go beyond both the excitement and the hype that comes with algorithms and the moral panics that accompany them. And that's the kind of mission that drives my work here at Stanford. So let's start with some definitions. Social scientists love definitions. We spend a lot of our time kind of just defining things. And so defining algorithms is actually more tricky than it seems. There are indeed many different definitions of what an algorithm is, and it's a bit unclear which one is the best one. So let me start with the kind of canonical definition of algorithms. That's the kind of classic computer science one, the one that has been around for the longest time. An algorithm is a procedure or a set of rules used in calculation and problem solving, and the idea is that you use it to solve a particular problem, right, or to deal with a specific task. Now, with this definition of an algorithm, I mean, basically everything is an algorithm, is a problem, right? Me opening the fridge, getting a bottle of milk, closing the fridge, that's an algorithm. I have a 10-month-old at home, me changing the diaper, putting the diaper in the diaper pail, putting a new diaper, putting the baby back on the ground, that's also an algorithm. So perhaps not particularly helpful given what we're talking about. Okay, second definition. Machine learning algorithms. So when we talk about algorithms, often, in fact, what we mean is machine learning algorithms. The capacity of computers to learn from experience, to modify their processing on the basis of newly acquired information. Kind of major example of that are the Facebook algorithm, the Google algorithm, the Amazon algorithm, the fact that depending on what you buy on Amazon, you're going to see kind of similar products or products you may be interested in pop up. And that's based on the algorithm kind of learning from your previous shopping experiences. So, that's good. What's interesting about these machine learning algorithms is that there is a whole infrastructure that goes kind of behind it. You need some kind of training data, you need some kind of model, neural network, that kind of things, decision trees. Then you test these kind of models on some kind of test data, and then you have your machine learning algorithms that kind of evolves on its own. But in fact, when we think about algorithms and when we see the headlines that I showed you at the beginning of the talk, it's not only about machine learning algorithms. In fact, I mean, there are lots of machine learning algorithms out there, and we've been talking about them this morning, but there are also many other algorithms that we keep thinking about and that scare us very much. And so this leads me to the third definition of algorithms that we see around a lot. And it's basically the stuff that computers and the internet do. And here, the main kind of idea is really that it's a metonymy, it's a metaphor. We think about algorithm, we talk about algorithms, but really what we mean is the internet, right? Is all the digital platforms that we spend time on, that we interact with, that we work on, from Slack channels to Facebook news feeds to Uber, kind of to other like cabs and everything. And the fact that more and more of our everyday experience is mediated through these digital platforms on mobile technologies and others. So here we see that the term algorithm really comes with this kind of confusing and overlapping meanings, and that part of the fear that we have and the hype that comes with algorithmic technologies is because they're never precisely defined, right? And so it's just kind of everything around us. And the idea that our lives are changing, we don't really know why, we don't know how, but that's kind of what's going on. So that's for the definition. And for now, we're not going to be more specific about what we mean by algorithms, because I think that the fact that there are so many conflicting definitions is itself important, because it shows that we have a deep cultural imaginaries about the roles that algorithmic technologies are playing in our lives. So we're going to leave it at that. Now, do algorithms have politics? Well, of course not. How could they, right? Algorithmic technologies are objective, they're efficient, they're numbers, they're calculations. Engineers are doing it. How could they have politics? So this is the idea, which I think is very present right now, and especially in the Valley, but in many other places as well, that algorithms have to be rational, objective, and efficient. In fact, we often rely on algorithms when we want to escape politics, right? When we say that human beings are too messy, that we're biased, that we're not efficient, that we're wasting resources, that we make mistakes, that we're not attentive, that we need to rest. Algorithms can save us from ourselves and from our political, social, and cultural biases. So there is this idea that historians and sociologists have called trust in number. The idea that numbers and technology come with a particular prestige, with a particular aura, and come with this idea that they're more objective than what we do, right? So how could algorithms be political? Well, to answer this question, I'm going to talk about something quite different. Who here is from New York? Very few people. Okay. Who knows about Robert Moses? Yay, excellent. So let me just jump back in time. This is not about algorithms, but I do think that it tells us something very important about how algorithms can be political. So Robert Moses was an urban planner who worked mostly in New York and in other areas between the 1930s and the 1970s. And he really transformed the infrastructure of the city. He created the Triborough Bridge, the Brooklyn-Queens Expressways, many different highways, bridges, to kind of connect Manhattan to all the different boroughs around it. And what's interesting about Robert Moses is that he really cared about leisure as well. And so he also created these big infrastructures near the sea, near the ocean. So this is Jones Beach with, you see, a big boardwalk, so kind of typical kind of a Coney Island kind of representation that we have. And the idea with these big structures is that people from the lower classes had the right to go to the beach, right? And had the right to enjoy these kind of leisure activities, that was part of what modern life in America was like, right? So he created all of these infrastructures. And he also created several highways, actually parkways, to go to these beaches. Now, the thing with these parkways is that he designed these bridges that went over the parkways that would go from Manhattan to the beach. And as you can see, this is actually a terrible picture, but the bridges are very low, right? A car can go under it, a high car, an SUV can go under it, but a bus can't. Now, what's interesting about this is that it also meant that people who didn't have a car weren't able to go to the beach. And who were people without a car in the 1950s? Mostly African Americans from low-income neighborhoods who could not take the bus to go to the beach and were de facto excluded from going to these very nice infrastructures that Robert Moses had designed. So this is the situation. Now, what's interesting about it is that there has been a heated debate about why this happened, right? So first interpretation, Moses was actually racist. He had a personal kind of set of negative feelings about African Americans and low-income people, and he just really wanted to exclude them very consciously from the nice infrastructures that he created on the ocean. And so he explicitly designed these low bridges to exclude them and exclude buses from going there. Okay, that's the first interpretation. Second interpretation, well, no, Moses was actually not racist, but all the parkways at the time had this kind of low bridges and were in fact excluding buses. And so it's not that Moses explicitly wanted to exclude African Americans. In fact, he was Jewish and he himself experienced discrimination. So it wasn't a conscious thing, but just, the infrastructures of the time did exclude buses for parkways. And so he just kind of went along with the flow, not thinking about how the infrastructures that he was designing could exclude kind of minorities and low-income people. Third interpretation, now, in fact, there were buses going to Jones Beach. And so this is just a moot debate. So I'm giving you here a very high-level description of what the field known as science and technology studies talks about when we talk about infrastructure. And the idea here is that there is a dialectical relationship between technology and society. So what does that mean? That means that on the one hand, social and political forces always shape technological artifacts. In turn, technological artifacts always shape social structures. So how does that work? In the cases of the bridges, it's pretty simple. Perhaps Moses was racist. That's a political belief. Perhaps, in fact, the whole parkway system was exclusionary. That's another political structure. And that, in turn, had real consequences in terms of inequality of access to the beaches for African Americans and low-income people, right? From social to technology to society, again, right? Perhaps it was something else, but we can adopt exactly the same metaphor to think about algorithms, with the idea that algorithms are always shaped by social and political forces, and in turn, they do shape the social structures in which we evolve. So let me give you another example. Facebook emoticons. That's more current. We're not talking about bridges anymore. Now, do you guys remember how Facebook changed the way in which we can react to our friends' posts? We used to have only the like button, and now we have all of these different emoticons. So now, that's a question for the group. What do you think are the social and political forces that shaped this change? What do you think happened? Yeah.
People started complaining because they wanted more emoticons and they felt like they were being represented or being able to express themselves accurately.
Yeah, but so how is that exactly? Well, it's just that, if you only have a like button, well, so you can only like articles, right? You don't have a range of expressions. But if you can only like articles, are you going to share an article that no one's going to like? For example, an article about the situation in Syria, right? And an article about a piece of news that's just like really, really sad and terrible. But you still feel that it's important for our friends to know about, and you care about this, but no one's going to like it, so you're not going to share it, right? Because if like is the only way of expressing yourself, why should you do this? So here again, you see this kind of circle between social and political forces and technological artifacts, right? They kind of move together. And then let's think about these new emoticons. So the idea here is that you would have a wider range of expression, and that in turn would kind of enhance engagement on the social media platform, which is what Facebook wants. It wants us to share as much as possible and spend as much time as possible on the platform. Do you notice anything about these emoticons? They're actually not white, they're kind of yellow. I mean, so that's kind of interesting, right? It's just like, we don't want to have them be white, but we just want a neutral color that's not going to offend anyone, so we're going to pick yellow, right? So that's also typically a way in which kind of social and political values, in fact, impact the way in which algorithms get built. Okay, so this brings me to this idea of the politics of algorithms. And these are some of the questions that I explore in my work. So let me just give you an overview of what's going on in my world, both in terms of what I'm teaching, what I'm researching, and the rest. So the kind of questions I'm interested in are the following. First, they're about construction. What kind of values are embedded into algorithms? What type of choices and biases shapes their constructions? How can we study that? Second, what are the internal features of algorithmic systems? How do they operate? When and how do they grow, scale? And what happens when an algorithm that was designed for a specific domain gets deployed in a domain that has nothing to do with the original set of features that the algorithm was designed to solve, right? What happens when the technology becomes global, right? What happens to cultural difference in that case? Third, on the reception side, what are the effects of algorithms on the social world? How do they shape our knowledge, interactions, and identities? And how do we use them? So let me talk a tiny bit about this class I'm teaching, called The Politics of Algorithms, here at Stanford. It's an amazing, amazing class. It's so much fun. So it's basically a class for undergrads. I have about 100 students. Half of them come from computer science and are going to work at major tech companies after they graduate. And I see it as an important political mission, actually, to teach them this kind of stuff because they're going to work in tech later on, and they're going to be the ones designing many of these technologies in the future. So in this class, which I teach in the spring, we talk about a range of things, from filter bubbles, right? How is Facebook changing the way in which we interact in the democratic public sphere? What's going on with echo chambers? How can we manipulate algorithms to kind of change the kind of discourses that get mediated in the public? We talk about algorithmic discrimination. What happens when, why is it that when you Google an African-American sounding first name, here, Latanya Farrell, you get an ad that says arrested, whereas when you Google a typically white-sounding first name, here, Kristen Herring, you don't get the mention arrested. What kind of processes are sustaining this kind of disparate impact on African-Americans and white people? We talk about predictive policing. What happens when data about arrest, which is itself very much structured by social and racial inequality in the US, gets embedded into machine learning algorithmic systems. We talk about algorithmic identities, substance, not just selfies. So what happens when romance is mediated through algorithms? When you trust an algorithm to meet your soulmate? What happens when you communicate with your friends through Instagram, Twitter, LinkedIn, and Facebook? How does that change the way in which we see ourselves and we present ourselves to our friends and lovers? And finally, regulation. This is a really tricky topic. How do you regulate algorithms? And in particular, how do you regulate machine learning algorithms? Now, this is really tricky, and it's tricky for many different reasons. First, because algorithms belong to major tech companies. It's intellectual property. It's not made public. Companies don't really want to share their codes for good reasons. So what does it even mean, right? But the second reason is that algorithms are opaque. So this is a machine learning algorithm that does recognition on numbers. And so basically, you can see the kind of intermediate layers of language that the algorithm has developed to make sense of the figures that it shows. And here, like, it's just, these algorithms are evolving all the time. No one, not even the engineers that design them, really understand what's going on in these intermediary layers. So what does it mean to regulate them, right? You can't have just one law or one set of regulations once and for all. You will have to do it regularly. So these are exactly the kind of hard questions that we talk about in my class and that the students hopefully learn from. Now to conclude, I'm going to talk a bit about my research. So as I said, I'm an ethnographer, and I'm really interested in the future of work and how the fact that we work with technologies, it's not us against the robots, it's usually us with artificial intelligence, us with algorithms. And so what I look at is how the kind of decisions we make in our work can be mediated through algorithmic technologies. So I do ethnographic fieldwork in 2 different kinds of fields right now, and I'm looking for a third case, so if you guys have ideas, I would very much welcome them. So I've been looking at web journalism and seeing how newsrooms basically rely on growing number of software programs to kind of get a sense of what readers want to read at any given moment, right? So in order to maximize traffic. And that in turn is used to kind of decide on which kind of headlines, which kind of placement on the homepage, what kind of strategy on social media platforms, and also what kind of topics to cover. And so I look at how journalists kind of deal with these technologies to decide what's important news, right? And what should they cover. And they don't always agree. Second, I look at criminal justice. So here it's the same thing. There is a long history of bias and discrimination in the US criminal justice system. And over the past 20 years, there has been a development of predictive algorithms to assess the risk of recidivism of defendants. And in many courthouses right now, judges and prosecutors are using these algorithms to make decisions. And so what I do is I follow these workers as they make decisions. I kind of try to understand how they react to these technologies, and I see what happens. And basically my two main findings so far is first this idea of decoupling. So basically there is a big difference between what people say they do with technology and what they actually do with technology. So when you ask them, it's like, oh, we love artificial intelligence, we love algorithms, we're so modern, we're completely on top of it. We're good, we're leading the field. And in fact, when you start spending time in a newsroom or in a criminal court, you see that the reality on the ground is always very different, and usually there is a lot of resistance to technological change among workers, right? And that's the second part of my research, which is that I look at the ways in which workers often resist algorithmic technologies, and the kind of strategies they put in place to basically not change the way they work, from foot dragging to gaming and manipulating the algorithms to get the results that they want, to open critique. And so I think that the take-home point from this kind of research is that when you're deploying some kind of new algorithm in a given organization, you have to be very, very careful about how people make sense of it, and about whether they find it helpful for their work or whether they find it threatening. Right? And so for that, you need in-depth kind of examinations of what's going on the ground, instead of just high level, like, yeah, we're going to change everything with technology, it's cool. Let me now conclude. So I've given you a kind of high-level overview of this growing field of research, which I'm part of, called critical algorithmic studies, or critical data studies. And I think that as a kind of final word, so we have these algorithmic technologies everywhere. They are mediating an increasing amount of activities, right? From workplaces to our houses, to how we interact, how we connect with others, how we shop, but also how we interact with public services, right? How we can be sentenced for crimes, all of these things. And so as our life is becoming more and more mediated through these kind of computational procedures, we need to study them. And to study them, we need interdisciplinary teams. We need people from industry and people from academia. We need computer scientists and we need social scientists. We need people from the humanities and people from engineering backgrounds. And so I will conclude with a call for more interdisciplinary research on the question of the politics of algorithms. Thank you.